This is problem number 34 from page 354 in the book, and it says this, that given this following data, 2O3s yields 3 O2s with a delta H of negative 427 kilojoules, and O2 yields 2 O's with a delta H of 495 kilojoules, and NO plus O3 yields NO2 and O2 with a delta H of negative 199 kilojoules, and we're supposed to calculate delta H for the reaction of NO plus O yields NO2. So we're going to apply Hess's law here, and so that means that we're going to have to take this, and this we're going to call the target equation. And so we're going to try to find this equation by rearranging the equations up here at the top so that we can get everything that we need in the correct position in the target equation down here. So here it is, a little smaller. We're going to look and see what we've got in the equation. We have NO on the reactant side, and if we look at the givens, NO is in the correct position on this given equation. We also have to have O by itself, and in the givens, O is by itself in this equation. So we're going to make note here of this one that we're going to have to do some changes to that one to get O in the right place. And then NO2 is here, so it's in the good position. But also looking at the target, the only thing that's in there is the NO, the O, and the NO2. So all this other stuff, all these things, are going to have to go away. So let's start with the O, because that's probably where we need to go first. NO is in the right place. O is not in the right place. So I'm going to work on this equation right here. So basically what I need to do with that one, I can see right away, is I need to reverse it. So I'm going to write it again. 2O yields O2. And when I reverse an equation, then I'm going to change the sign. So delta H over here will be negative 495 kilojoules. All right, this equation now has been changed, so I don't want to go back and use it again. All right, but what that's going to show me is now I've got O in the right place, but I've got O2s and O3s around here that need to go away because they're not in the target. So I'm looking at this equation here, which has got the NO and the NO2 in the right place, which has got O3s and O2s all over the place that have to go away. So because I see there's an O3 right here, I'm going to go up to this equation right here and do some manipulation of it. So if O3 is on the reactant side here, it needs to be on the product side up here, so I need to reverse this equation. So I've got 3O2 yields 2O3, and delta H then gets its sign changed again to plus 427 kilojoules. All right, so now this equation has been changed, so I'm going to get rid of it. Now let's just kind of look ahead at what we've got going on here. So NO is in the right place for the target. We now have an O in the right place here for the target. We got NO2 in the right place. We just need to get rid of O3, which we just helped do that by what we just finished. And we need to get rid of an O2. But it looks like O2 right here will be in the right place for that. But let's just have a look here at what we need to do. Let's see, if we want to get rid of this O3 right here, we probably need to, let's see, we could divide this equation right here by 2. Divide this by 2. So this becomes 3 halves O2 yields O3, and delta H will be half of what it was before. So 213.5, we'll call it 214 kilojoules. All right, so I have now changed this equation, so I'm going to get rid of that. All right, so again, just kind of inventorying what we've got. NO's in the right place. Now I've got O3's in the right place on both sides. And I just got to look and see what O2 looks like. Let's see. So I have an O2 right here in this equation, and I have a 3 halves O2 over here on this side. All right, that's going to make this a little tricky, but I also recognize that this right here has a 2 in front of the O, and in the target up here, it's just a 1. So let's go through and let's divide this equation right here by 2. going to run out of room here. So it's O yields 1/2 O2, and delta H will be half of 495, which is 297.5. We'll call it 298. That's negative kilojoules. Okay, so I think we're getting somewhere, but let's stop now and let's go on to part 2, and we'll kind of finish this up and clean up some of this mess. So go on to part 2 now.